Hey guys, these are our notes for Unit 4B.1.2, which is on constraints. It's going to go into our digital notebook on slide 9 through 11. So at the top of your paper, you can put your title, Notes 4B.1.2 Constraints. So basically constraints, when it says that, is constraints are basically just restrictions on real-world problems. So we're just going to have some sort of restrictions when we're doing our word problems. We'll talk about kind of what some of those things are. A reminder about domain and range is that domain is your x values. Those are your independent values. And then your range is your y values. These are your dependent. So you're not always going to have x and y though. You might have distance and time. So, time is independent of anything, and then the distance depends on how long you've been traveling, that sort of thing. So when we're talking about some real world constraints, some different ones, it depends on what your word problem, is talking about. But some examples would be like time is positive. So you would have to make sure that you set your time greater than or equal to 0. Another constraint will be something like people or items must be whole numbers. Just anything that the problem might mention to you. It might have some sort of restriction on what kind of discount you can get. We see that in one of our examples. Just some sort of, you have so much money you're allowed to spend. You can't go over it. So just depending on your problem, there's different constraints or restrictions that you can have. So let's do, this is an example that's similar to some of your classwork or your homework problems. It says find the restricted domain given by the range restriction. So write out your problem and then write out your little statement. So it gave us an equation and it says y is equal to 2x plus 7. So that's a linear equation. But it gave us this restriction. It says that y has to be greater than 15. So there's a restriction on our problem. Our range, our y value, has to be greater than 15. So basically what we're going to do is kind of like a substitution. We know what y is equal to. Y is equal to 2x plus 7. So I'm just going to plug that in for this y right here. 2x plus 7 has to be greater than 15. And then it just says find the restricted domain, which is your x values. So I'm just going to solve for x. Subtract 7 on both sides. I get 15 minus 7 is 8. Divide both sides by 2, and I get x has to be greater than 4. So that is my domain restriction. So if they're going to give me the restriction that the range has to be greater than 15, then my domain has to be greater than 4. So you have similar problems like that on your homework tonight. All right, let's go ahead and grab our workbook. This is workbook unit 4B. This should be page 19. Our problem says, Meredith runs the souvenir store for a minor league baseball team. She checked into how much it would cost to have smartphone cases made that feature an image of the team's mascot. One manufacturer charges $250 design fee to design and print the personalized cases, plus the cost of each actual cases. The first 50 cases cost $5 each. The next 100 cases cost $3 each. Write an equation to determine how many cases Meredith can purchase with a budget of $7.50. Determine the constraints of the terms of the equation based on the situation. Then apply the constraints to solve for the number of cases that can be purchased. We're not actually going to use, you guys have more on page 19. I only have 1 through 4 because it was on like a whole nother page, and I just don't want to use both of those. We're not really going to follow along with their steps. We're just going to kind of show our work over here on the side. So the first thing, it says like write an equation in words, but that's not something that you're going to write down every single time, but you can kind of think about it in your head. It says that there's a $250 fee to design. That's a flat fee. So that's like your y-intercept. There's nothing attached to it. Plus you have the cost of the actual cases. The first 50 cases cost $5 each. So that's $5 per case. So that's a slope. But then it says the next 100 cases cost $3 each. $3 each, that's another slope. It says write an equation, determine how many cases Meredith can purchase. Here in our problem, it says something about the cost, and it tells us to use N and M. It says use N for the cases that are $5 each, and it says use M if the number of cases that are $3 each. So we're going to go ahead and use those variables. Okay, so we pay a $250 fee no matter what. Okay, so that $250 fee we pay no matter what. Plus we have to pay for our cases. Well, the first 50 cases cost $5 each, so they told us to use the letter N, so that would be plus 5N. And then they told us to use M for the $3 cases, so then we would say plus 3M. And we have a budget of $750, so that means we can be equal to $750, or we can be less than $750, but we can't go over. That's just our budget. So we're not going to have an equal sign. We're just going to have a less than or equal to, because we can be less than that. That's just our budget. All right, so we want to put on some restrictions though. So N, okay, is the number of cases. So some restrictions are we can't have negative cases, right? So it has to be greater than or equal to 0. But this is only for the first 50 cases that cost $5 each. So what that means is that this N is going to be less than or equal to 50. Then our letter M, okay, also a number of cases, that can't be negative, so it can be from 0 up to the next 100 cases, so it can go over to 100. So we have an equation, we determined our constraints. It was like the first two things the problem asked us to do. It said write an equation, determine the constraints, so that's the first part of our answer. Then it asked us to determine how many cases she can purchase, right? So we wanted to figure out how many she can purchase with $750. What we're going to do first is we're going to go ahead and assume that she can, we'll plug it in and see if it works out. We're going to assume she can buy all 50 of the $5 cases. So we have 250 plus 5 times 50 plus 3M. We don't know how many of the $3 cases she can buy yet. That's what we're going to try to figure out. But we're going to assume that she's buying all 50 of the $5 cases. So I get 250 plus 5 times 50 is 250 plus 3M less than or equal to 750. And keep solving. 250 plus 250 is 500. So I'm going to subtract 500 on both sides. And we still have some money left over, right? We have our $3 cases. We have $250 that we can spend on those $3 cases, because $750 minus 500 is $250. I'm going to go ahead and divide both sides by 3. I would get out my calculator because I don't know 250 divided by 3 off the top of my head. So 250 divided by 3, I get 83.33. 83.3 repeating. All right, well, we're talking about cases. So when we're talking about cases, can we have 0.3 of a case? No. So how many cases can she buy? This is our real world constraint. So if we rounded up to 84, she wouldn't have enough money. So we're going to have to round down to 83 of these $3 cases. These are the $3 ones. Well, she bought already some $5 cases. She bought 50 of those $5 cases. So total, she bought 50 plus 83. So she can buy 133 cases total. So for our word problem, okay, we had two kind of variables. We had our $5 cases and our $3 cases. We just went ahead and assumed she bought all 50. She could go to a maximum of 50. We said she bought a maximum of the $55 cases. That left her with $250 to spend on the $3 cases. That gave us a decimal. We had to round down in order to be able to afford them. So here's our $3 cases, our $5 cases. That's 133 cases total. All right, let's keep going. Example 2, it says certain medical tests require that patients be injected with liquids containing trace amounts of radioactive elements in order to track the movement of blood in the circulatory system. So like they'll inject you and then they'll put you under some sort of scan and they'll be able to see the radioactive element that's going through your blood to make sure everything's, through your veins, everything's working. It says the concentration of the radioactive tracer substance diminishes in the human body over time according to the function C of t equals A, parentheses 2 minus t divided by 1 plus 4t minus t squared, in which A is a constant unique to the tracer, it just has to be greater than 0. T is the time in hours, and C of t is the concentration of the tracer in milligrams per liter. Identify any real-world and mathematical constraints on T. The time for the tracer is in the body, which allows C of t to be determined in context of the situation. All right, so what they're saying is, any real-world scenarios, okay? We're talking about T, time, so we know something like time can't be negative, right? We're going to start our time clock at 0. We want to find at what time then all of our concentration is gone from the body, okay? So we're going to set our C of t equal to 0. And now we're going to solve for t so we can find what time all of our radioactive substance is gone. So first off, this A value, it just says that A is a number greater than 0. We're just going to divide both sides by A. Cancels here. 0 divided by anything is just 0. So I have 0 equals now what was in my parentheses. All right, I'm going to solve. I want to get my fraction gone. So the way that we get rid of dividing by something is we're just going to multiply both sides by 1 plus 4t minus t squared. Cancels. Well, anything times 0 is just 0, so I get 0 equals 2 minus t. Remember, I'm trying to solve for t, so I'm just going to add t to both sides, and I get t equals 2. So remember, we said that is when the substance, or the concentration gets down to 0, when all of it's gone. It's not going to stay in your body forever. So what we have then is time, okay? It's all gone at 2 hours, and we said that time has to be positive, so we had to start the time at 0, and we end the time at 2 because that's when it's gone. So basically what these numbers mean is this is when you are injected, right? This is when you start. That's when time starts, and then at 2 hours, that's when it's all gone. It's I don't know, is it your heart that cleans out your kidneys? I don't know, whatever cleans your blood. Okay, so your real world constraints are that time has to be positive and all of the concentration is gone after 2 hours. So if you want to figure out how much is in the body, it has to be between those 2 hours. All right, last example. It says a sporting goods store is running a sale to eliminate inventory of a discontinued tennis racket. The price of the racket can be marked down as much as necessary to make sure all the rackets are sold. However, the total revenue from selling all of the rackets cannot be less than $7,500. The shop has already sold 50 of the 62 rackets at the full price of $130 per racket. Write an equation to find the minimum price at which the remaining rackets can be sold while meeting the sales quota. Then find the maximum percentage reduction by which the remaining rackets can be marked down, assuming that the store can only mark down items in units of 5%. Use the number to determine the actual sale price of the remaining rackets and the total revenue generated once all the rackets have sold. All right, so there's a lot of stipulations here, a lot of restrictions. Told us that the total revenue cannot be less than $7,500. It told us that they already sold 50 of the 62 rackets for full price. They want us to write an equation to find the minimum price at which the remaining rackets can be sold while still meeting the sales quota. They told us that the maximum percentage reduction has to be marked down in units of 5%. So you can be marked down 10, 20, 15, 25, 75%, but it can't be marked down like 3%, 18%, 27%. It has to be in units of 5. So then they want us to use this number to determine the actual sale price of the remaining rackets and the total revenue. So we have a lot of stuff that they want us to solve for. All right, so let's get started. So it says, we'll find the maximum percentage reduction. So there's 4 things we got to find. All right, so let's get started. It said they already sold 50 of the 62 rackets at $130. Okay, so they already sold 50 rackets at $130. If they sold 50 of 62, that means there's 12 rackets left to solve. We're going to figure out X, how much they want us to sell it at. They didn't tell us, I don't think, a variable to use, so I'm just going to use X. But we do know that it cannot be less than $7,500. So this number needs to be greater than or equal to $7,500. So these are the rackets that are already sold. These are the rackets we have left. We have to figure out how much we can sell them for, and we know that we have to make profit more than $7,500 for the revenue. All right, let's go ahead and solve this now. That's the first part, the writing an equation. Now we're going to solve it. So 50 times 130, I already did this earlier, or I get my calculator. It's 6,500, so I'm going to subtract that on both sides. So I get 12x equal or less, greater than or equal to 7,500 minus 6,500 is 1,000. Then I'm going to go ahead and divide both sides by 12, and we actually get the same thing as our first problem we had before, 83.3 repeating. So this is the minimum that we can sell our racket for, okay? That's the minimum we can sell it for. But we can only mark things down in increments of 5%. So let's figure out what percentage we can mark it down. So 83 point, we're going to do 3 because we're talking about dollars, right? So we have dollars and cents. We're going to divide that by the original cost of 130. And that means that this price is 64.1%, right? That means that that is, what, 35.9% off. Because 64.1 plus 35.9, that would equal 100%. Well, we can't mark it down by way too big. We can't mark it down by 35.9% off. We have to go down in increments of 5%. So what we're going to do is we're only going to mark it down 35%. So we're going to mark it down 35% instead. So that means we can, it said find the maximum percentage reduction. It's going to be 35% max. That was one of the other things we had to find. So what price would that be? The actual sale price. So if it was 130 times, it's 35% off. That means that you're paying 65% of the cost. So it's not times 65 actually, it's times 0.65. So that means that 130 times 0.65 is $84.50. So it was a minimum we could sell was 83.33, but we're going to sell it for $84.50 because we can't do 35.9% off. We can only do increments of 5, so we have to do 35% off. Then the last thing it wants us to find is the total revenue that we got. So we had the 50 rackets at 130 plus 12 rackets at 84.5. And when you add that all up, I used my calculator earlier. I think it's $7,514. That's your total revenue. So did we make it? That's more than 7,500, so we're good. If we would have sold it for 40% off, we wouldn't have made our total revenue that we needed. So we had to sell it for 35% off max. All right, so your homework problems, you're going to have these real world restrictions, constraints on there of, stipulations about your problem. So your notes are going to go on slide 9, 10, and 11. And then your homework is out of the workbook as well, page 23, I believe.